CRAN small cell selection add-in tool in the ATOL. Input, you need CRAN candidate node list, densification zone, polygon, focus zone, polygon, traffic map which is used for the ATOL project, and then you need a station template for all the possible CRAN node solution. There are 4 CRAN nodes which can be used for the densification. This stage 1 is called picocell, 5 watt and maximum 35 feet. It's below clutter. And then the next stage is micro CRAN node. It comes with 3 flavors: 8 watt, 12 watt and 20 watt. So create a session template for all the 4 possible solution. Then configure the add-in as shown in the picture. You select the candidate node as for the small cell site location. Then select the focus zone for the small cell deployment zone, and then maximum number of the small cell is normally a trigger sector, macrosector multiplied by 8, and then resolution is 5, and then you select the small cells session template, which template you want to use in order to create a node. Then clutter, you use all the important clutter, select all the important clutter. I'll leave the like forest water kind of clutter. And the select throughput optimization, traffic map, you select all the like voice and data traffic map used for your ATOL setup. And service is FTP, terminal is like category 6 MIMO terminal, and mobility pedestrian. And after that you run the say OK and let the SCP tool take place. So for the micro, like there are 4 flavors, right? So play 4 is pico, 5 watt, 30 feet. Play 2 is micro, 12 watt, 49 feet. And micro 20 watt is 59 feet, and 8 watt is 37 feet. So for micro, 37 feet, 49 feet and 59 feet. And this is the way you set up the candidate list actually. So you have a name, and you have lat long, then template name, which we basically used, like pico for stage 1 pico, 5 watt, 30 feet. And then site class, like which kind of transport link is used for the front haul. So it's like fiber from your BBU to the node, pico node, and then the antenna height, which is like in the meter, 9.2 meter. And let SCP run and select the node. So and you can see in the real time what is actually how the SCP is working. First it runs a path loss for all the nodes, and then it started optimizing the design actually, and you can see in the real time how the SINR, PTCS, PDSU SINR is improving, RS SINR, RSRP. You can see the total cost. Once the ACP is done with this job, you can go and see the ACP summary scenario for the optimization. Go to optimization, see how the improvement took place for the SINR, PDSCH and RSRP, and you can also see the change details. Once you are satisfied, do the commit, and after committing, the changes will be imported into the at all. Then you run Monte Carlo simulation, and after that you run the KPIs, optimize KPI. And for the deliverable, let me just show you how the KPIs actually looks like. So that's how it is actually. In the first slide you are showing the map with all this microsite and the possible node locations, and you are also in the table also here showing the number of nodes before and after the design. And it also, in the second table, you show the baseline RLC throughput, average throughput, and average RLC average throughput for the optimized design. And then next slide you are showing cluster with the node location, and then you're also showing the node with a traffic map, and then you show the terrain map with all this different kind of nodes like micro, pico, and all this kind of thing, and then you show the regular one, and the show then next one you show the KPIs actually, and you show the VoLTE user, mean server user, VoLTE, RSRP, user dominance, aggregated throughput, and the major criteria here is you show the number of nodes before the design and after design, and show the capacity coefficient, and then you show the aggregate throughput before and after design, and then your optimized throughput must be baseline throughput multiplied by capacity coefficients. And then there are some graphs, and then you show SINR before and after for the densification zone, and then you show where the BPUs is going to be located, hub, and then this you can also show one slide showing the efficiency of each and every node. That's it.